Integration 2, example 2. This is another example of integration by substitution. And again, if you look at this integral, it's not something that you would easily be able to do just by looking at it. I've noticed that there's a dx missing off the end of here, so you need to squeeze that in before we start. So, first step always is to differentiate whatever substitution you're given. So if we differentiate this substitution, again you can see why it's been chosen, x squared plus 1, that's that complicated power up here, so you can see why that's been chosen. Differentiate it, you get 2x, and if we just rearrange it, du is 2x dx. Looking at the actual integral then, if we look at the different parts of it, e to the x squared plus 1 is obviously e to the u. Now, this is where you've got to sort of look at what you've got actually in the question, because there's an x here at the front and there's a dx at the end. Now we have an x and a dx here, so we can put those together. If I just rearrange this, if I divide both sides by 2, a half du is the same as x dx. So we can tackle both of those two bits at once, the x at the front and the dx at the end, combined to give a half du. So rather than looking at them separately and coming up with an expression for them separately, we can look at them together. X dx can be written as a half du, and it's always worth looking out for that when you've done this derivative at the beginning. See if you can get more than one part of the integral out of this derivative here. So the x and the dx we're going to replace by a half, which I'll put at the front, du. So x and dx have been dealt with, and we've got e to the u. So we've dealt with all the parts of the original integral. Nice easy integral just becomes half e to the u again, and then we can replace the u by the x squared plus 1, which we had originally. Make sure it all looks like a power, and then because it's the final line we put plus c. So the crucial bit to notice in this question is the x and the dx in the question combining to give this part of what you get when you differentiate u, and that's something to look out for in every question.